Hi, my name is Rahul and I'm going to be teaching you how to approach problems in three-dimensional geometry and understand how to apply the formulae so that solving this becomes real easy. Now, we've got a question as you can see on your screen. Find the equation of the plane passing through a point -1, 3, 2 and perpendicular to each of the planes x plus 2y plus 3z equal to 5 and 3x plus 3y plus z equal to 0. So let's go ahead with the problem. So now, as we know that the equation of a plane is given by a x minus x1 plus b y minus y1 plus c z minus z1. So basically this formula has a, b and c, which are direction ratios of the normal to the plane. Now a normal to the plane is basically a line that comes out of the plane. Okay, it comes out perpendicular to the surface of the plane. So if this sheet of paper was a plane, this pen standing right here is your normal to the plane. So for a plane you need your normals and you need a point, as in your x1, y1 and z1. So out here we've been given -1, 3, 2. So -1, 3 and 2 becomes the point through which your plane passes. So we have sorted out x1, y1 and z1. Now the thing that arises is the next condition. This plane is passing through these two planes and it says that perpendicular to each of these two planes. Now if you remember vectors, there are two vectors. A vector perpendicular to two vectors can be obtained by using cross product. So basically the crossing of two vectors gives you a vector in perpendicular to both the vectors. So if I had a vector and I crossed it with another vector called b vector, I would get a vector c, and this c is perpendicular to both a and b. So what do you infer? Now what are the direction ratios of these two planes given? So the first plane is x plus 2y plus 3z equal to 5, and the next plane is 3x plus 3y plus z equals 0. So the normal to the planes in this case is 1x, that is 1, comma 2, comma 3. The direction ratio of the normals is this, and the direction ratio of the normal to this plane is 3, 3 and 1. So we can write the direction ratio as a vector as this 1, 2, 3 in vector form will be I cap plus 2j cap plus 3k cap. So this is the normal for this plane, and the next normal can be written in vector form as 3i plus 3j plus k cap. Now we consider this as an a vector and we consider this as a b vector. So our a vector cross b vector can be found using our way of how we normally find vectors. So that will go as I cap, j cap, k cap. It will be 1, 2, 3, 3, 3, 1. So this is nothing but your I cap 2 minus 9 minus j cap 1 minus 9, you can get it minus 1 minus 9 plus k cap, sorry this doesn't look like a k cap 3 minus 6. So the end result that you get is minus 7i plus 8j minus 3k. So as you can see, we have obtained a normal that is perpendicular to both a vector and b vector. So we will term this as c vector. And c vector is nothing but the normal a, b and c that we require for our desired equation for the plane. So over here if we simply write it as a equals minus 7, b equals 8 and c equals minus 3. So this is basically c vector is normal of the resultant two vectors. Now substituting back in our equations, a x minus x1 plus b y minus y1 plus c z minus z1 equals 0. What do we get? We substitute the point 1 minus 1 3 2 as x1 y1 and z1 and a, b and c as we have obtained above. So there we go. We will get minus 7 times x plus 7 plus 8 times y minus 3 plus minus 3 times z minus 2. So this is nothing but minus 7x plus 8y minus 3z minus 67 equals 0. So this is our final equation. So basically we know our formula as ax minus x1, by minus y1, cz minus z1. So we know x1, y1 and z1 is a point, but the real challenge is obtaining the normals, that is a, b and c. So once you get the normal, and getting the normals is through the given condition. So in this case it was perpendicular to each of the planes. So a plane is nothing but, say, this surface, and you have something coming out perpendicular to it. So if you have another plane, say this, okay, it has another surface coming out like this. So basically you have two lines crossing each other, okay, and if you take a cross product of those two, you will get a line in perpendicular to both of those lines in three-dimensional space, and that is found by your given vector cross product, and we substitute it into the equation. So that's how you approach these problems. Thank you for watching.